Now we would like to look at a past question, and the question says write down and simplify all the terms of the binomial expansion. And the binomial expansion is open bracket 1 minus x close bracket raised to power 6. So we have to expand this completely. All right. B part says use your expansion to evaluate 0.997 raised to power 6. Correct to 4 decimal places. This point is emphatical. We need to take note of this point. It's very important because instructional. And then C, they said when 0.9976 was computed by a student, his result was 0.9817. All right. We to find the percentage error, correct to 3. Again, another very instructional point we must take note of, or to 3 decimal places. This is very important so that at the end of your answers, if you round off the result, it has to be to 4 decimal places, and then the last part has to be to 3 decimal places. So we are going to look at how this could be solved right away. So let's take the first part and say write down and simplify all the terms of the binomial expansion. So dealing with A1, we take this first, and that's going to be 1 minus x, everything raised to power 6. We remember that using binomial theorem, if that is the simplest one for you, because here there is no restriction. All right, you can use any of the theorems, either Pascal's theorem, or you use binomial expansion or the general formula, binomial theorem or the general formula for binomial expansion. So I would choose to use the binomial theorem. Of course, you know 6 combination 0, then we have 1 raised to power 6, we have minus x raised to power 0, and then the next term is 6 combination 1, then we have 1 raised to power 5, you have minus x raised to power 1. The next one would be 6 combination 2, and then you have 1 raised to power 4, you have minus x raised to power 2, then plus. The next one is 6 combination 3, of course this is raised to power 4. Alright, then we have 1 raised to power 3, then we have minus x raised to power 3, then we have 6 combination 4, we have 1 raised to power 2, of course it's multiplying, so all this dot signifies multiplication. Alright, in mathematics, when it comes to long expansion, if you see dot like this, what they mean is multiplication, right? So the next one is minus x raised to power 4, and then we have 6 combination 5, we have 1 raised to power 1, then we have this raised to power 5. Finally, we have 6 combination 6, we have 1 raised to power 0, then times minus x, everything raised to power 6. So the expansion is as we see there. Of course, I told us before, so this is 1, and this one again is 1 because it's raised to power 0. So the result is equal to 1 times 1, because 1 raised to power 6 is 1, then we have 1. So it's going to be like the first term positive because of this minus, the second one is going to be negative. The power here is even, so the next term is positive, and then this one is odd, so it's going to be negative in that order of alternation. So the next one we are going to, if you work on this, you are going to have 6 combination 1 is going to give you 6, then times 1, then times x. So the next one, this 6 combination 2, if you take your time to work it, that's going to be 6 times 6, then 4 factorial, that's going to give you 15. 15 times 1, then you have times x squared. So the next one, if you have, you work this one out, that's likely to give you 20, all right? If you 6 combination, this is going to be, if you do all that, that's going to be minus 20, and then you have x raised to power 3. So the next one, if you work this, all right, is going to go for 6 combination. This 4 we go then to 3. That's likely to give you, I think, 15x raised to power 4. And then the next one, which is 5, if you do this, this is going to give you 6 again. It's going to give you 6x raised to power 5, and the last one is going to give you plus x raised to power 6. Right, so try do your own simplification and see. So if you do this, you're going to have 1 minus 6x, and then we have plus 15x squared minus 20x cubed plus 15x raised to power 4 minus 6x raised to power 5, and then we have x raised to power 6. So this is therefore the expansion of that. Very interesting, you would say. So B, they said we should use our expansion to want to evaluate 0.997 raised to power 6. Now, when this sort of thing is given to you, the first thing to do is to express this value to look like the original binomial expansion. All right, so this language, this thing here could also be expressed, or you can say that it's equivalent to 1 minus 0.003, right? Yeah, 0.003, everything raised to power 6, because if you subtract this, you're going to get this, all right, which looks more like the form of this 1 minus x, and then 1 minus 0.003, all right, giving also this result. So if you compare this expression with this, all right, compare 1 minus x raised to power 6 and 1 minus 0.03, everything raised to power 6, we can say that our x is equal to 0.003, right? If you compare this, if you equate this to equate this, it means x takes the position of 0.006, every other thing being equal. So what we are going to do in this case is we substitute the value of x here into the original expression, right, in a way that it will give us 4 decimal places, right? So if you do this, it means that our 1 minus 0.003, everything raised to power 6, go in the order of expansion is going to be 1 minus 6 into 0.03. The next one is 20 into 0.003, everything raised to power, excuse me, I think the next one is 15, so sorry about that. So this is going to give us 15, this is it, raised to power 2 plus 20 into 0.003 everything raised to power 3. It continues like that. If you evaluate this, it's already in 4 decimal places, so the continuation of the expansion is immaterial. So if you do this, what you're going to have, compute this result. This time, that's going to be 1 minus, I think you have 0.018 plus, if you compute this, it's likely to be 0.00, I think 135, or not really sure, but if you work it out and then you evaluate, your result is likely to be something like this, 0.9821. Okay, so this is, when you have done it like this, then you have to state 4 decimal places, because that forms part of the instruction. All right, it should be 1, 2, 3, 4 decimal places. All right, this is very interesting. Then they told us that there is a student who attempted this question and had a result of student result. All right. If a student's result is equal to 0.9817, then error, because there's certainly error. If this is the real result and this is what the student arrived at, the error is going to be 0.9821 minus 0.9817, and that's going to give you 0.00, I think 4 blah blah blah. It's going to continue like that. So the percentage error, therefore, our percentage error is equal to error over real value times 100%. If you do that, it's going to be 0.012. All right. Well, I think it's 3 zeros. Very likely to be 3 zeros or something. 3 zeros, something like this. So you have 0.4 divided by 0.9821 times 100%, and that's going to give you 0.0. Then you have 41%. Of course, that is to 3 decimal places again, as requested by the question. Thank you.